The Yasen-class guided missile submarine is the one Russian naval asset that this series will not use for humor. The K-560 Severodvinsk and her sisters are among the most capable submarines in the world. Their Caliber cruise missiles have a range that covers most of Europe from a launch point in the Barents Sea. Their acoustic signature, while not as quiet as the best American submarines, is sufficiently reduced from previous Russian designs that the dismissive characterization that applies to the Russian surface fleet's maintenance challenges does not apply here. The Yasen-class was designed carefully, built with the specific goal of closing the acoustic gap with Western submarines, and represents the current state of Russian submarine engineering at its most serious. This series treats the Kilo-class's installation in Iranian hands with appropriate respect. The Yasen-class gets the same respect, without qualifier. What the Yasen-class does produce, not from any technical deficiency, but from the operational reality of its employment, is an intelligence collection opportunity of the kind that the United States Navy's submarine force has been specifically engineering itself to exploit for 50 years. The Yasen operates in the Barents Sea, the Norwegian Sea, and the North Atlantic, in waters that the US Navy has been listening to with fixed hydrophone arrays, patrol submarines, and maritime patrol aircraft since the Cold War. The listening infrastructure is extensive, patient, and has been accumulating data on Russian submarine acoustic signatures since the era of the Yankee class. When a Yasen deploys, the intelligence picture moves from the library to the operational record. The specific library entry for the Yasen class has been good. The direct operational collection against a deployed hull under real conditions is always better. USS Connecticut, SSN-22, a Seawolf-class attack submarine, commissioned in 1998, the second of 3 Seawolves built before the class was canceled in favor of the Virginia class, is in the Barents Sea. She is here because the Barents Sea is where Russian nuclear submarines operate, and because one of her hull class's specific design objectives was to operate in exactly this environment against exactly this kind of adversary. The Seawolf-class was designed at the height of the Cold War to defeat Soviet submarines in their home waters, and the design philosophy produced a submarine that is, in every relevant metric, speed, diving depth, sonar capability, quietness, weapons load, the most capable attack submarine the United States has ever built. 3 were made. The Cold War ended. The Navy decided the Virginia class was a more cost-effective approach to the new environment. The Seawolves that exist are extraordinary. The number that exist is limited. USS Connecticut, being in the Barents Sea, is a statement about how seriously the relevant command authorities assess the target she is tracking. The Yasen-class submarine, USS Connecticut, has been tracking for the past 6 hours and 11 minutes is the Kazan, the second hull of the Yasen-M improved subclass, commissioned in 2021 with the updated weapon systems and reduced acoustic signature that the Yasen-M improvements were designed to produce. The Kazan's acoustic signature is quieter than the Severodvinsk's. Quieter than the Severodvinsk is not the same as quiet in the absolute sense, because the United States has been working the problem of detecting advanced Russian submarines for longer than the Kazan's crew has been alive. The Seawolf's AN/BSY-2 combat system and the BQQ-10 sonar suite, optimized specifically for the Barents Sea's acoustic environment, found the Kazan 6 hours and 11 minutes ago and has been maintaining contact since. The Kazan is at approximately 3.8 nautical miles from USS Connecticut's current position. This is close. The specific operational geometry that has produced this proximity is the result of a deliberate positioning decision by USS Connecticut's commanding officer 4 hours ago, when the initial tracking geometry was favorable and he chose to decrease the separation in order to improve the collection quality. Decreasing separation with a Yasen-M in the Barents Sea is not a casual decision. It is a decision made by someone who has high confidence in his ship's quietness, high confidence in his crew's professionalism, and a specific collection objective that requires close-range data that standoff tracking cannot achieve. The commanding officer made that decision. The commanding officer's confidence was justified. The time is 9:17. The Barents Sea in February has a thermocline structure that the oceanographic model has characterized this morning as moderately favorable for the collection geometry at this range. The deep sound channel is accessible below the mixed layer. The Kazan is at approximately 280 meters depth on a northwest course at 12 knots, a transit speed rather than a patrol speed, suggesting the Kazan is heading for her operating area rather than operating in it. The contact history over 6 hours and 11 minutes shows 2 speed changes, 3 course changes, and 1 period of approximately 40 minutes, during which the Kazan was at a slower speed and appears from the acoustic picture to have been conducting her own sonar sweep of the surrounding water. The sweep produced no response from USS Connecticut's direction, which is operationally satisfying in the specific way that not being detected by a Yasen-M is satisfying. Here is the vulnerability window, and it requires a different kind of explanation than the hardware-based windows elsewhere in this series, because it involves something that submarines almost never discuss in open sources. At 9:17, USS Connecticut detects a transient. A transient is a brief, non-periodic acoustic event, something that happened once, produced a sound, and stopped. In the open ocean acoustic environment, transients are common. Biologics, flow noise, far-field shipping. The specific transient detected at 0917 on bearing 035, slightly off the Kazan's bearing of 020, is not a biologic and not shipping. It is metallic, brief, inconsistent with any known acoustic artifact in USS Connecticut's contact history for the past 6 hours. The sonar operator reports it at 091714. She marks the bearing. She marks the frequency content. She marks the duration, approximately 0.4 seconds. A 0.4 second metallic transient on a bearing close to a Yasen-M submarine is one of the items on the list of acoustic events that submarine sonar operators are trained to take seriously. The transient could be a biologic's tail slap, which is not a joke description. Large marine mammals produce brief metallic adjacent transients that have confused submarines before and after. The transient could be an internal equipment noise from the Kazan, a valve actuation, a mechanism adjustment, a door closure in the engineering spaces. Internal equipment noise from a Yasen-M at 3.8 miles in the Barents Sea's current acoustic conditions is detectable. Or the transient could be something else. The something else that is on the mind of every sonar operator in this situation is not comfortable. The specific bearing of the transient, 035, which is 15 degrees offset from the Kazan's bearing of 020, is consistent with a second contact, a second acoustic source on a different bearing. In the Barents Sea in February, in the operating area of a Yasen-M, a second contact on a different bearing means a second submarine. And a second submarine in the Kazan's vicinity, operating on a bearing that is not USS Connecticut's bearing, is a contact that USS Connecticut needs to localize. This is the vulnerability window. Not a maintenance cycle, not a mechanical failure. The possibility of 2 submarines in the same operating area, with the second not yet classified or localized. The vulnerability is not to USS Connecticut's position. USS Connecticut is quiet and has not been detected by the Kazan, and the transient is almost certainly the Kazan's own machinery rather than a second contact. The vulnerability is to the collection mission. If there are 2 Russian submarines in this operating area, and USS Connecticut has been tracking one for 6 hours and 11 minutes without being aware of the other, the collection picture is incomplete in a way that matters. The commanding officer needs to resolve the transient's origin before he can be confident in his understanding of the tactical picture. At 9:19, the sonar operator reports, transient classification uncertain, bearing 035, 1 contact, possibly equipment noise from the Kazan's engineering spaces, possibly an independent acoustic source on an adjacent bearing. I cannot classify at this time. This is the correct professional answer when the evidence is ambiguous. USS Connecticut's commanding officer reviews the contact picture. He reviews the transient's frequency content. He makes a decision. Passive listen for 5 minutes on the transient bearing before taking any action. 5 minutes at the current closing geometry is manageable. If the transient is an independent contact, it will produce another acoustic event within 5 minutes that allows classification. If it does not, the commanding officer's working hypothesis is Kazan equipment noise. At 0924, no additional transients from bearing 035. The sonar operator's assessment, Kazan equipment noise, consistent with a valve actuation in the engineering spaces. The commanding officer concurs. The tactical picture remains single contact, Kazan on bearing 020. The 5-minute passive listen is over. What the 5-minute passive listen produced is not only the transient classification, it produced 5 minutes of additional collection on the Kazan at close range, during a period when the Kazan appears to have undergone a minor speed reduction from 12 knots to approximately 10, that the contact history has not previously observed. A 2-knot speed reduction at 9:19, lasting approximately 6 minutes before returning to 12 knots. The Kazan did something in her engineering spaces at 0917 that produced a transient, and whatever she did was associated with a minor speed reduction. The correlation between the transient and the speed change is in the collection record. It tells analysts something about the Kazan's engineering systems and their relationship to propulsion that existing library data has not previously characterized. Let us now discuss what USS Connecticut is collecting, because the intelligence product from a Seawolf-class submarine at close range on a Yasen-M is not a routine library update. It is the closest thing to reading the Kazan's engineering manual that can be achieved without a copy of the engineering manual. The BQQ-10 sonar suite on USS Connecticut has been building the Kazan's acoustic profile since first detection at 3:06 this morning. The profile includes the broadband noise floor, the sum total of all machinery noise the Kazan produces, across the frequency spectrum, from the very low frequency range, where nuclear submarines are most detectable, to the mid-frequency range, where specific machinery components produce tonal signatures. The Kazan's reactor coolant pumps produce tonals at predictable frequencies that are related to their rotation rate. The Kazan's propeller produces a blade rate signature that is related to its rotation speed and number of blades. The Kazan's auxiliary machinery, pumps, compressors, ventilation systems, each produce characteristic signatures at known frequencies. All of these are in the collection record, measured at close range, in the specific Arctic water conditions that represent the Kazan's home acoustic environment. What is new this morning? New compared to the existing Yasen-M library entry, which was built from previous collections at longer range and from analysis of the Severodvinsk's older acoustic profile, is the propeller blade rate at 12 knots, which is the specific combination of speed and blade configuration that the Kazan has been maintaining for the past 6 hours. At 12 knots, the blade rate produces a signature that the existing library entry had characterized from analysis of the Severodvinsk's propeller at lower speeds. Direct measurement at 12 knots on the Kazan's specific propeller, which may differ from the Severodvinsk's and the Yasen-M improvements, is new data. The blade rate at 12 knots is in the collection record. The blade rate at 12 knots is lower than the Severodvinsk's entry at comparable speed. The sonar operator notes at 0931, reviewing the spectral analysis of the contact. That is consistent with a larger diameter propeller or a different blade count. Either way, the signature is distinct. She marks the measurement. The propeller characterization is the most significant single acoustic datum in the 6-hour collection. A propeller signature characterization at operational speed is the specific measurement that sonar classification algorithms depend on for positive identification at long range. The Kazan's propeller, measured this morning at 12 knots in the Barents Sea, goes into the NATO Acoustic Intelligence Library as a confirmed direct measurement. The next time the Kazan's blade rate appears in a sonar operator's display, anywhere in the Atlantic or Arctic, it will be recognized. The collection also includes 3 separate instances of the Kazan conducting what appear to be reactor power adjustments, brief periods of reactor thermal signature change that are detectable from the acoustic signatures of the cooling system's response to the power change. Reactor power adjustments are associated with speed changes or with the specific maintenance actions that nuclear reactors require periodically. The three instances in the collection record, correlated with the contact's speed history, show that the Kazan adjusts reactor power at slightly different rates than the Severodvinsk's existing profile suggests. The adjustment rate is a function of the reactor control system's design parameters. The adjustment rate tells analysts something about the Kazan's specific reactor configuration. All three events are in the collection record. At 9:44, the Kazan begins a slow turn to the west. The turn is gradual, approximately 3 degrees per minute, consistent with a course change for navigational reasons rather than a reactive turn in response to a detection event. The turn will take the Kazan to a new course that points her northwest, into deeper water and toward the Norwegian Sea. This is consistent with the mission profile assessment that characterized this deployment as a Barents Sea to Norwegian Sea transit. The Kazan is doing what was expected. The intelligence picture is confirmed by the contact's behavior. USS Connecticut adjusts her position to maintain tracking geometry through the turn. The turn takes 11 minutes. During the 11 minutes of the turn, USS Connecticut's sonar has a continuously changing bearing angle to the Kazan, which, in the specific way that bearing angle change during a submarine maneuver produces geometric information, allows the sonar team to refine their range estimate for the Kazan's position. The range estimate at 0955 after the turn is 4.1 nautical miles versus the 3.8 mile estimate before the turn. The Kazan has increased range slightly during the turn geometry. USS Connecticut adjusts her course to maintain the 3.8 mile baseline. At 10:03, USS Connecticut receives a VLF communications check that includes an intelligence update from Submarine Force Atlantic. The update includes a refreshed assessment of the Kazan's mission profile, based on the most recent collection from the Fixed Hydrophone Array Network in the Barents Sea approaches. The assessment confirms the Norwegian Sea transit profile. The update also notes that a second Yasen-M, the Novosibirsk, the fourth hull, was observed departing Severodvinsk 4 days ago and has not been subsequently tracked. Novosibirsk's current position is assessed as unknown. The update advises Connecticut to be aware of the possibility of a second Yasen-M in the operating area. The commanding officer reads the Novosibirsk assessment. He reviews the transient from 9:17. He reviews the 5 minutes of passive listening on bearing 035 that produced no additional acoustic events. He reviews his confidence assessment on the transient classification as Kazan equipment noise. He notes that the Novosibirsk's last known position was Severodvinsk 4 days ago, and that the transit time from Severodvinsk to the current operating area is within the range that 4 days represents. He makes a note in the tactical log. The note is not alarming. It is the professional notation of a commanding officer who has new information that bears on a previous classification and wants to ensure the record shows that the information was received and considered. The transient classification remains Kazan equipment noise. The note exists. The collection continues through 10:47, when a mission time limit requires USS Connecticut to begin her transit to the communications window that will allow her to transmit the contact report. The total tracking duration, 7 hours and 41 minutes. The total contact history is one of the most complete single deployment acoustic profiles of a Yasen-M submarine in NATO's library. The propeller blade rate at 12 knots. The reactor power adjustment rates. The machinery signature in the engineering spaces during the 0917 minor event. The maneuver acoustic data from the 11-minute turn. All of it in the record. The contact report runs to 38 pages. It is transmitted at 14:22 during USS Connecticut's communications window. The 38 pages go to Submarine Force Atlantic, to the Naval Intelligence Support Center's Russian Submarine Acoustic Program, to the NATO Maritime Intelligence Center, and to the intelligence services of the United Kingdom, Norway, and France, the 3 NATO allies whose submarine forces operate regularly in the Norwegian Sea and Barents Sea, and whose ASW assets will be the next to encounter the Kazan in the approaches to the Norwegian Sea. The UK's Submarine Service receives the propeller blade rate measurement with specific interest because the Royal Navy's Astute-class submarines have been waiting for exactly this measurement to calibrate their classification algorithm update for the Yasen-M class. The UK liaison officer's response note arrives at 16:03 and requests the full spectral data file, not just the summary. The full file is transmitted at 16:47. The Kazan is by this time in the Norwegian Sea, making 12 knots northwest, proceeding on her patrol. Her crew does not know they were tracked for 7 hours and 41 minutes in the Barents Sea. They conducted their sonar sweeps. They detected no contacts. Their counter-detection protocol returned an assessment of clear water around them. The assessment was incorrect for 7 hours and 41 minutes, and the incorrectness of that assessment is now 38 pages in 5 inboxes and a spectral data file that the Royal Navy's Astute classification team is currently opening. The commanding officer of USS Connecticut is completing his patrol report addendum at 15:11. The addendum covers the collection highlights, the transient event and its resolution, the Novosibirsk advisory, and the collection quality assessment. He rates the collection quality as exceptional, which is the highest rating in the patrol report's quality scale, and which he has applied to the collection with the specific confidence of someone who has spent a career in submarines, knowing the difference between good collection and collection that changes things. The propeller blade rate at 12 knots changes things. The reactor adjustment rate changes things. 38 pages of Barents Sea Yasen-M tracking from a Seawolf at 3.8 miles changes things. He also notes, in the personal annotation that goes in his private log rather than the official record, that the Novosibirsk note from the 10:03 update will keep him thinking about the 0917 transient. He classified it as equipment noise. His confidence is high. His confidence is not certainty. In the Barents Sea, in the vicinity of a Yasen-M, when the intelligence picture notes a second Yasen-M unaccounted for, high confidence is the honest assessment, and it coexists with the professional alertness that distinguishes people who are good at this work from people who are merely trained at it. He makes the note. He picks up his coffee. The Barents Sea is dark and cold, and 3 years removed from a different Seawolf incident in this part of the ocean, and the work continues. Bye for now.